Welcome to our VM600Mk2 SIL webinar. SIL stands for Safety Integrity Levels. Natural question would be, why do we need SIL? In mid-1980s, a series of high-profile accidents, especially in the process industry, resulted in significant damage to the material property as well as the human life. This resulted in certain industry standards and practices to be implemented to improve the process safety. The safety integrity levels, SIL, were introduced especially for the electric and electronic safety related systems. SIL 1 would mean that the risk is reduced by a factor of 10. SIL 2 would mean the risk is reduced by a factor of 100. What does this really mean? This means that the reduction in likelihood of missed trip for the machinery measurements that are used as part of safety critical loop. To give you an example, the thrust bearing failure, if it goes undetected, results in the release of toxic gases. Even the excessive radial vibration failures will open up seals, resulting in the release of toxic gases. Therefore, the SIL is an important safety aspect that needs to be implemented in the machinery protection and monitoring system. So Megit has designed VM600Mk2 to be SIL compliant by design, whereas our Mark 1 generation was SIL certified by proven in use. This time, to reduce the waiting time for our customers, we have decided to implement the SIL by design for the Mark II. My colleagues Ricardo and Alfonso will give you more details on the SIL design concept as well as the Mark II SIL capability.
Hello. I'm sure you already asked yourself this question. Should I use SIL or standard equipment? Or why do I need SIL? Or even, is SIL always better than non-SIL? Well, like any other question, it is important to understand the context before jumping into a conclusion. If you are looking for a protection system, it means that you are facing a certain risk and that you want to put in place measures that allow you to reduce this risk. So your first step is to evaluate how much risk you are dealing with, how probably it is to happen and how severe it can be. Then you will put in place the measures that you consider enough to reduce the risk down to an acceptable level. Let's make the parallel with your day-to-day life. For example, if you will move your car just a few meters, you may choose to not fasten your seatbelt. However, if you go for a drive, then for sure you will fasten it. And this is a practical example of risk evaluation and mitigation measures that we apply every day. The choice to use or not our seatbelt is based on different subjective and objective aspects. It will depend on your own past experiences and your own subjective evaluation of the risk. But it is also dictated by norms and standards. There are applicable laws that force you to do it, and also standards that define how the seatbelts are built and how they shall be used. And this is basically the same for a protection system. You can also use your own judgment and also a set of standards. These functional safety standards will guide you into the evaluation of the risk and also into the quantification of the risk reduction factors that you need to apply, again to bring it down to acceptable levels. More specifically, the functional safety standard, IEC 61508, is a generic safety standard that allows for the development of a uniform technical approach that can be applied to all safety systems in electronics and related software. Then we have other standards more specific to each type of industry. How do they do it? Well, to ensure a certain degree of safety and the best chances of avoiding as much as possible malfunctions of your safety instrumented system, being due to a random hardware fail or to a systematic type of fail, the functional safety standards cover the entire life cycle of the system, from the concept to the decommissioning or disposal of the equipment. And this is in fact the main difference between SIL and non-SIL device. While for the SIL one, you know that the entire life cycle is respected, And again, this means all aspects from design, development, production, commission and decommissioning. For a non-SIL device, these aspects are eventually also covered, but not in a standard and independently verified way. They will depend mainly on the manufacturer. So, in practical terms, the major difference is that a SIL certified equipment is developed and operated based on a standardized process, as we saw, while a non-SIL one may follow quality standards, but not necessarily the ones that dictated to functional safety. Now, we cannot say that one is better than the other. For example, good reputable companies have such good processes that the difference is less relevant. Don't forget that the IEC 61508 is in fact a generic standard of good practices for functional safety. So reputed manufacturers, you should not expect many differences. The second difference is linked to the fact that you apply a standard, and whenever you apply a standard, you lose some flexibility. You may have noticed that the safety manual of SIL equipment restricts the usage of SIL equipment to specific operational conditions. That is to say, it dictates the operational conditions for which the system was specifically designed for. All usage restrictions must be respected to ensure safety. On the other hand, a non-SIL equipment is normally designed for a wider range of operational conditions, hence tends to be more flexible. The third aspect is a bit more controversial and is often misunderstood. Of course, a safety system must have good availability. However, its primary focus is on safety. So, as it will include many more internal diagnostic measures, availability will be sacrificed somehow. The spurious trip rate is directly related with the extension of internal diagnostics in the equipment. A non-SIL system is typically less complex and with less internal diagnostics, so it will have eventually a higher availability. For example, a non-SIL system will continue to operate even if some functions are slightly degraded, but for a SIL equipment this is seldom accepted. Whenever there is an issue with the equipment potentially affecting the safety function, the system shall fall into a safe state, typically meaning that the trip of the machine will occur. Note that you can increase the availability of a safety system by increasing the number of equipment in parallel, for example using a 2 out of 3 architecture. Finally, we have the cost associated with each type of equipment. A non-SIL has typically a lower acquisition and maintenance cost compared to an equivalent SIL equipment. The reason is that the SIL equipment not only requires heavier documentation, safety calculations and testing, but it also requires additional development and parts for the internal diagnostics. So the development becomes more expensive. Also, operating cost is higher for a SIL device, because you will need to test it regularly with dedicated procedures and eventually replace it more often to maintain the safety properties of the entire system. You may need also to have some sort of redundancy to increase the availability for the system. So, when to use SIL? The short answer is whenever you need formal compliance with functional safety standards, when you have a critical system, safety-wise, and when you are ready to sacrifice some flexibility. The decision, however, must always be validated by the functional safety responsibility of the site. Only him can judge the relevance of SIL or not, and if the SIL level is appropriated to implement the safety instrumented function or system, and hence if it provides the required risk reduction factor.
Hello everyone. Now I'm going to give you an introduction to the technical differences between the standard cards and the new SIL certified cards we are going to launch in Q1 2023. So, as you know, on the VM600Mk2 we have 3 types of cards at the moment. We have the CPU-M Mk2, then we have the MPC4 Mk2 with where you can configure a full protection system and do condition monitoring on top of that. And then we have RLC16 Mk2 in case additional relays are required. So if there are not enough relays for the customer requirements on the MPC4. So my goal for today's webinar is to introduce you to the differences between these 2 types of cards. And I have here the agenda, is the differences between these 2 types of cards, and we are going to just go over it. So the first difference to mention is physical difference. So the cards are not the same. The electronic components are different. The layout, the routing of the components is different. So they are different cards, and you can see that on the electronic card itself, or even from the front when they are installed. You can see the top and bottom tabs to be able to push them or remove them is different. So in case of the SIL, you can see the SIL term written there, and the background is the background color is yellow versus the gray background color that we have on the standard one. So one reason for having different electronic components is because while on the standard card we have only software segregation between protection and monitoring, so we have two different pieces of firmware, we have two different processes to manage protection and monitoring. On the hardware side, it's those two processes are running on the same CPUs, on the same memory. On the SIL version, on the MPC4 SIL, we went one step ahead, and we have segregation both on the software level and even on the hardware level. So we have separate CPUs and memory to segregate protection and monitoring. Okay, so that's the first difference, which is a physical difference. Then, in terms of how we manage, how we configure these cards, there is not much difference between MPC4 standard and MPC4 SIL. We need to use vibro-meter protect software to configure the card, and vibro-meter system manager to set IP addresses, NTP server, upgrade firmware, etc. You can see here on the slide a screenshot of the vibro-meter protect software. You see behind the rack, and here we can add to the rack layout whatever cards are located in the different slots. And in vibro-meter we will have, instead of the option to add MPC4 and RLC16 standard, we will have 4 cards now with the addition of the SIL versions. So it's as simple as that. We need to configure a SIL system, we need to add the SIL version of the card and then configure them as we usually do for the standard version. In terms of card capabilities, if we talk about input channels, both standard and SIL have 4 dynamic input channels and 2 quasi-static input channels. But there is a difference regarding the speed channels. On the standard card, we can connect 2 speed sensors. On the SIL version, only one speed sensor is allowed, is supported. If we talk about relays, both cards have 4 physical relays and 1 card fault relay. Okay. But in case of the SIL card, those relays have to be handled as relay pairs, as pairs of relays. So relay number 1 and number 2 are linked and are managed as relay pair number 1, and relay 3 and 4 as relay pair number 2. That means that if we configure some machine shutdown logic on a logical function, we are going to connect that logic to relay pair number 1 or relay pair number 2, but it's not possible to manage the relays individually. So that same principle applies to the RLC16. So on the SIL version, we have 16 physical relays, but they have to be managed as 8 relay pairs. So we can connect a logical function from an MPC4 to one of those 8 relay pairs. There are restrictions on the SIL side regarding the configuration of those relays that applies to the remote relays on RLC16 and as well to the local relays on MPC4. So in a standard card, we can decide to configure them as normally energized or normally de-energized, and as well as latched or non-latched. The SIL certification imposes that the relays have to be normally energized and have to be latched. So there is no other choice on the vibro-side protect software for the SIL cards. Another difference is regarding serial numbers. In vibro-side protect, to configure an MPC4 standard, is necessary to enter the card serial number. On the SIL card, is necessary to enter two serial numbers. The serial number of the front card, the MPC4, and the serial number of the back card, the IOC4. In case of the SIL, if you replace the IOC4 by a new one, the firmware will detect that the serial number in the configuration doesn't match the serial number actually on the card and will go to safe state. On the standard version, that will not happen. You can freely replace the IOC and the system will continue doing its protection function. Then the SIL certification imposes an additional step to set up the rack. So an standard MPC4 has to be configured, and that configuration has to be activated to the rack via the Ethernet cable. And that's it. The card will do its job. It will protect the machine. In case of the SIL card, there is an additional step which is necessary, which is called to the signature of the configuration. So a typical process would be to configure the card in the same way as we do for the standard, then inject signals, validate the logic works as expected, everything is properly configured, and when that process finishes, and that process might imply some, configuring the card several times until we get rid of all the potential issues. When that process is finished, there is one last step of signature, and in that step, someone has to do that, to sign the card, and in the card itself, it will be recorded the name entered by the person, the name of the computer from which it was signed the card, the timestamp with date and time, and the CRC of the protection configuration. All that will be stored on the card. That means we can come a few months later or years later and check that signature using vibro-side System Manager or vibro-side Protect, and we can be certain that nobody changed the protection configuration. So the signature has the proper date and the proper CRC, and everything is untouched. Another difference is that in case of the standard card, it can do the protection function either being locked or being unlocked. That's a choice we leave to the customer, to each application. In some cases, for certain customers, can be useful to do the protection and leave the card unlocked. Maybe the card is installed in a remote location and the network is cyber secure, and it's really convenient to be able to maintain the card, apply changes or do modifications without requiring going to next to the rack to unlock the card. Nevertheless, this approach is not allowed when we talk about the SIL version of the card. For the card, I mean, it will protect the card once it's configured and the configuration is signed. But when the card is locked, there are additional validations, additional diagnostics that are run, and without those additional diagnostics, the card itself doesn't meet the SIL requirements. So it is mandatory, and it will be stated in that way in the SIL manual. It is mandatory to lock the card, for it to be sealed. There is another difference in terms of diagnosis. As I mentioned, the standard card is doing some diagnosis on the power up. That's why it takes a few minutes to power it up. Same applies to SIL. But then there are some additional tests that are run while the configuration is running. So they are all the time monitoring the health of the card itself. So it's important to note that in case of the SIL, the coverage of that auto-diagnosis of potential failures on the card has a larger coverage. So is more comprehensive. An example of that is that the memory, the physical memory on the card, on the SIL version has self-correcting capabilities. So it can detect some errors if maybe a cosmic ray comes from the universe and changes a few bits on the memory. The memory will detect that, and it's capable to correct those errors, of course, to a certain extent. On the input channels, on the dynamic input channels, when we measure a dynamic signal, we have the option to configure a digital filter to concentrate, to do protection based on a certain frequency range on that signal. For that, we configure a high pass cutoff frequency and a low pass cutoff frequency. So the characteristics of that digital filter are different between the standard and the SIL. In case of the standard, the high pass cutoff frequency can go up to 15 kilohertz. In case of the SIL, it can go only from 0 hertz to 400 hertz. There is another difference regarding the usage of the VM600 buses. So as you know, the VM600 has 3 internal buses for inter-card communication within the rack. We have RAW bus, TACO bus, and OC bus. So both cards are capable of sending signals to the RAW bus, signals from sensors. So that is to allow doing protection in one MPC4 card, and then you can have the sensors connected to the MPC4, and then they are sent to the RAW bus, and they can be received by an XMV card that will do the condition monitoring function. So in that way, we have segregation at the level of cards between protection and monitoring. So both SIL and non-SIL can do that, and the same applies for sending sensor signals from TACO signals to the RAW bus, but the difference comes when we talk about receiving a TACO signal from the TACO bus. The standard card can receive the speed signal via the TACO bus. So maybe we are monitoring one machine, and we need multiple MPC4s, but the speed of the machine is the same for all the MPC4s. In case of the standard cards, we can connect that speed sensor to one of those MPC4s, and the other ones will receive that speed signal via the TACO bus. The SIL card must work in isolation. It cannot depend on another card on the rack. So that's why on the SIL card, the TACO signal must be directly connected to the SIL card itself. So no TACO bus reading is allowed. Then if we talk about the OC bus, this is the bus which is used to drive relays on RLC16. The SIL card can only use the OC bus for that. The standard card can use the RAW bus for communicating with remote relays, but in case of the SIL card, that is not allowed, to avoid a potential mistake, a potential conflict between cards in the rack. And then it's important to mention that MPC4 SIL can only drive. Okay, you cannot mix MPC4 standard with relay card RLC16 SIL or vice versa. In the MPC4 standard, there is one interesting feature, which is the fact that the configuration, the protection configuration, is stored on the IOC card itself. There is a memory on the IOC where the configuration is stored. That means that if the MPC4 fails, it can be directly replaced, and the IOC4 will configure the MPC4. So there is no software intervention required, no reconfiguration of the card. That is not allowed on the SIL card. That does not meet the SIL requirements. So in case of SIL, if the MPC4 has to be replaced, the card has to be reconfigured and the configuration has to be resigned using vibro-side protect. Okay, so here this slide is just a summary of all these differences that I described. And in summary, both standard and SIL cards do the same. They do protection and they can do condition monitoring. But there are some slight differences between them and some restrictions that must be taken into account in case of the SIL cards.